Let's start with the lock. Sometimes we need some synchronized in our Java program, and we used to use some conditions with wait function or using semaphores. But there's actually another way to implement the synchronized code, which is the lock. The lock is an object in Java you can use by import this package. To implement a lock in synchronized code, we might need a reentrant lock. So let's say this simple. There are two friends who are allowed to bond to each other, but only one is bound to and another one should not stop the bond. So in class friend, we have a lock which used to avoid mutual exclusion. This lock will check if there is a thread who holds this lock. If there is, the try lock function will return false, and because it has the return value, it will not stop, so it will not wait. So no deadlock at all. By the way, here I use the random to replace the random, which is did the totally same work but much more safer in concurrent system. Let's check out. It totally work. So next one is the executor thread. Executor interface. Sorry, this interface is imported from the package, and also others. We will cover it later. Executor provides a method execute which need a random object and let us to replace the code to create a thread and create a random object and let the thread to run to use start method to run. And now we can just use a simple way to do that by using the executor method execute. Generally, it did the same thing as start. We could create a new thread inside the executor, but depending on the implementation, executor prefer to use exist thread to run the random object, or push the object to the queue for waiting on a variable thread. The existed thread will come from thread pool, which I will cover it after the executor service. So executor service works similar, but it also accepts the callable object, but we don't have time to cover it in this video. And there also a scheduled executor service in package which executes the tasks by schedule, so we can execute after some delay. Now I'm gonna introduce the thread pool to create the executor service. There are three methods to create a thread pool, executor service. Which the first one is cached, which allows us to extension. So the next one is a fixed. We need a number to limit the number in the pool. So and another one is the single thread executor, which only allowed one task at a time. So all of them will keep the number of the pool by creating a replacement until it is shut down. So for example, this pool will always have 5 threads in this. Always have 5 threads. So for this one, it will only one thread in this pool. Could be any number of threads. So let's see how it works. So this is the output, and it shows that we have evoked it successfully. So next one is the forks are simple. Sometimes we need to consider the program of complexity of our program. Fortunately, Java also gives us a tool to take some advantage of multiple processors, the fork and join. The fork join is an implementation of executor service which could help us to split the task to several pieces and improve the performance. The simple here, I want the code to do some work directly if it's not too hard for it. So otherwise it will split the task to two parts and recursively do that until it's okay for his capacity. The last one I'm going to introduce is the automatic variable. In Java, when we try to change the variable, the global variable, we always use the synchronized keyword to make sure it will not be interrupted by other process, like we did in first assignment. Now we could use a much more easier way to do that. We could turn the operation to be automatic by simply initialize as automatic variable. After this, we could just invoke the increment and decrement method to change the value. It will much safer than the synchronized. Also, Java provides several different tabs for different situations. It is convenient for our program.
Now let's talk about AKKA. AKKA is an actor model written by Scala. It's compatible with Scala and Java. The actor model in computer science is a mathematical model of concurrent computation that treats actor as a universal primitives of concurrent computation. And what KKA can do? AKKA can build powerful concurrent and distribute application more easily. It encapsulates all kinds of complicated things in concurrent operation. The only thing we need to concern is the realization of business logic. And what is actor? Actors are objects that encapsulate states and behavior. The only way to communicate is to exchange message. The messages are placed in mailbox. That is, the actor do not communicate directly. An actor can do many things. It receives message and act on them by sending message, changing state, and changing its behavior and creating more actors. Now let's look at the grid example. First is the grid class. There are another three classes inside. The root grid class manages root grid obviously. The grid class is to execute the grid operation. The grid class contains the grid message and print actor. The override function handles message from its class type. If root grid class, it creates a greeting sentence. If grid class, it tells the print actor to print a message. Now it's the printer class. The printer class is to receive the message and print. It's easy to understand as the grid class. Now let's focus on the main class. First, we need the actor system to manage all actors. Then we create different pipes with different class type and message. Now we say hello to different objects without the sender's information. If you run this program, we can see there are different results if you run multiple times because it's concurrent program. And that is basically all the things about the AKKA. Thanks for watching.